Welcome to this Pre 50 class on mathematics. On today's topic we have indices, logarithm, standard form and sorts. Section 1 we will look at indices, and in section 2 logarithm. Section 3 we have standard form, and then finally in section 4 we'll be dealing with sorts. Objectives. At the end of this lecture, candidates should be able to apply the laws of indices in calculation, establish the relationship between indices and logarithms in solving problems, solve problems in different bases in logarithms, simplify and rationalize sorts, and 5. Perform basic operation and sorts. So these are the objectives of this topic. Indices. Numbers such as a raised to the power 5, b raised to the power 3, and 2 raised to the power 7 are in index forms, where a, b, and z. Sorry, this is z, not 2. Z raised to the power 7. So where a, b, and z are the bases. Bases as in B-A-S-E, while 5, 3, and 7 are the powers. So A is the base and 5 is the power. B is the base and 3 is the power. Z is the base, this is Z. Z is the base and 7 is the power. The plural of index is indices. Laws of indices. Now we're going to look at the different laws of indices. Let us now look at some relationships among numbers in index forms. If a is equal to 0 and m and n are integers, that is, they are negative or positive numbers, the following laws hold. We have a raised to the power m times a raised to the power n is equal to a raised to the power m plus n, and this is a law of multiplication. So when you are given two index forms with the same base, you just have to add up the power retaining the base. So here we have a raised to the power m times a raised to the power n. To solve this, we'll take one of the bases since they're in the same base. So you just take a raised to the power m plus n, and that's law of multiplication. For law of division, we have a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n, just the opposite of law of multiplication. So if the index forms are in the same base, you just add up their powers for multiplication and subtract their powers for division. Examples. Simplify the following. Number 1, 3a raised to the power 4, 3a raised to the power 4b raised to the power minus 5 times minus 2a raised to the power 2b raised to the power 8. 30x raised to the power 5y raised to the power minus 2 divided by 6x raised to the power minus 3 y raised to the power minus 5. Number 3, 3 raised to the power minus 5d all over 9 raised to the power 1 over 9. 3 raised to the power minus 5 over d all over 9 raised to the power 1 minus 9 times 27 raised to the power d plus 1. Number 4, 3x times 3 raised to the power minus x. So we'll now look at the solutions to these questions. Solution to number 1. In number 1, we have 3a raised to the power 4, b raised to the power minus 5 times minus 2a raised to the power 2, b raised to the power 8. So we solve 3a, 3 times, 3a raised to the power 4, b raised to the power minus 5 is equal to 3 times a raised to the power 4 times b raised to power minus 5. So that's why we have 3 times a raised to power 4 times b raised to power minus 5 times minus 2 times a raised to power 2 times b raised to power 8. So we collect like terms. 3 times minus 2 times a raised to power 4 times a raised to power 2 times b raised to power minus 5 times b raised to power 8. So you bring the a's together, the b's together, and then 3 and 2 together. So 3 times minus 2 is minus 6. A raised to power 4 times a raised to power 2 is equal to a raised to power 4 plus 2. Remember the law of multiplication. And then b raised to power minus 5 times b raised to power 8 is equal to b raised to power minus 5 plus 8. So when you multiply through, you have minus 6 times a raised to power 6 times b raised to power 3. You know that minus 5 plus 8 is 3. So we have your final answer to be minus 6a raised to power 6, b raised to power 3. And this is your answer. Note, just multiply numbers with numbers and letters with letters. So you multiply, when you are collecting like terms, you multiply 3 to 2, just like we did here, not 3 to a. The two a's should come together, the b's come together, and then the numbers will also come together. And then add powers of like letters together, and do not add the powers of unlike letters. Example, a raised to power 3 times b raised to power 4 is not equal to, that is, it is neither a raised to power 3 plus 4 nor b raised to power 3 plus 4. So just like in the question we just solved, you multiply the a's together and multiply the b's together. You don't multiply the a and b together. That is, you don't add the powers of a and b together because they are not the same thing. You cannot just do like in this question, a raised to power 4, you now do a raised to power 4 plus minus 5, which is for b. It will not work. So you handle a's and add the powers of a's if you are dealing with multiplication. If it's division, you subtract the powers of a's, after which you go over to b. So add powers of like letters together and do not add the powers of unlike letters. Solution to number 2. 30x raised to power 5, y raised to power minus 2, divided by 6x minus 3, 6x raised to power minus 3, y raised to power minus 5. So this is equal to 30x raised to power 5, y raised to power minus 2, all over 6x raised to power minus 3, y raised to power minus 5. So to solve, we have 5x, 6 divided by 30. 6 divided by 30 divided by 6, sorry. You have 5. So 5 times x raised to power 5. Remember in division, you subtract powers of like bases. So we have x here raised to power 5 and x here raised to power minus 3. So to divide, we subtract minus 3 from 5. So we'll have 5x raised to power 5 minus 3. And then for y, we do the same thing. We'll subtract minus 5 from minus 2. Note, it is not the other way around. Since this one, 30x raised to power 5, y raised to power minus 2, is to be divided by 6x raised to power minus 3, y raised to power minus 5. You subtract the powers of this x and y from this one. So it's minus 3. You subtract minus 3 from 5 and not subtracting 5 from minus 3. So that's why we have it here. For y, we have minus 2 minus 5 and not minus 5 minus 2. So you are subtracting this side from this side, the powers of this side from the powers of this side. So let's continue. So 5x, 5 minus 3 is equal to 5 plus 3. Minus times minus is plus. So 5x raised to power 5 plus 3 y minus 2 plus 5. So we have the final answer to be equal to 5x raised to power 8 y raised to power 3. Solution to number 3, question number 3. 3 minus 5d all over 3 raised to power minus 5d all over 9 raised to power 1 minus d times 27 raised to power d plus 1. So you divide through and then you multiply. So we solve 3 raised to power minus 5 over d all over 3 raised to power 2 bracket 1 minus d. Remember that 9 is equal to 3 raised to power 2. That is 3 times 3. So we change this 9 to 3 raised to power 2, and that is why we have 2 here. So it's 3 raised to power minus 5 over d all over 3 raised to power 2 bracket 1 minus d. So we use these 2 to open up this bracket. Multiply everything inside this bracket by 2 times 3 raised to power 3 bracket d plus 1. We also change 27 to base 3. 27 is equal to 3 raised to power 3. So that is why we have this 3 here. 3 raised to power 3 bracket d plus 1. We also use this 3 to multiply everything in this bracket. So it's equal to 3 raised to power minus 5d divided by 3 raised to power 2 minus 2d. When you open up the bracket, you have 2 minus 2d times 3 raised to power 3d plus 3. So since they are all in the same base, we just first subtract the power of this one, 2 minus 2d, from minus 5d, then add the power of this one, that is 3d plus 3. So we have 3 raised to power minus 5d minus 2 minus 2d plus 3d plus 3 equal to 3 minus 5d minus 2d plus 2d plus 3d plus 3 equal to 3 raised to power minus 5d plus 5d minus 2 plus 3. So minus 5d plus 5d is equal to 0, and minus 2 plus 3 is equal to 1. So we have the answer to be equal to 3 raised to power 1, and 3 raised to power 1 is equal to 3. And this is your final answer. Note what happened here. Minus 2 was this minus sign was used to open up this bracket. So minus 2 times 2 is minus 2, and minus times 2 is minus 2, and minus times minus 2d is equal to plus 2d. So that is how we arrived at this minus 2 plus 2d. And when you add and subtract, you have your answer to be 3. Solution to question number 4. 3 raised to power x times 3 raised to power minus x. Since they are in the same base, which is 3, we just add up the powers. So we have 3 raised to power x plus minus x, which is equal to 3 raised to power x minus x, equal to 3 raised to power 0. And anything raised to power 0 is 1. So we have our final answer to be 1. Continuation on laws of indices. So we are still on laws of indices. A raised to power m bracket n is equal to a raised to power m times n, which is equal to a raised to power mn. And this is the law of product of indices. Remember that a is the base and this is the power m bracket n. So law of product of indices says that a raised to power m times n is equal to a raised to power mn. Just multiply the bases. The powers. A raised to power 0 is equal to 1. 0 law for index. Anything raised to power 0 is equal to 1. A raised to power minus m is equal to 1 over a raised to power m. And this is the law for negative index. That is, a over 1 raised to power minus m is equal to 1 over a raised to power m. Look at what happened. It was a over 1, now it is 1 over a raised to power m. M is no longer in a minus. So, and it's equal to 1m over a raised to power m, which is equal to 1 over a raised to power m. So that is to say that a raised to power minus m is equal to 1 over a raised to power m. Any number raised to negative number index or power is equal to the reciprocal or reverse of the number raised to the same but positive index or power. Example: it says that any number raised to negative index or negative power is equal to the reciprocal of the number that is raised, and the number will be raised to the same but positive index. Look at what happened here. A over m raised to power minus m is equal to b over a raised to power m. Simply put, a raised to power minus 2 is equal to 1 over a raised to power 2. That is an illustration of the law of negative index. Examples: simplify the following. Minus 3 bracket x squared y cubed, that's x raised to power 2 y raised to power 3, all raised to power 5. Number 2, x raised to power minus 9 divided by y raised to power 0. 3 bracket minus 4m squared n, all raised to power 3. Number 4, minus 4x squared y raised to power minus 4, all in brackets raised to power 2, all over x 8xy. Solutions. Number 1, minus 3 bracket x squared y cubed raised to power 5 is equal to minus 3x 2 times 5 y raised to minus 3x raised to power 2 times 5 y raised to power 3 times 5. We multiplied by 5 because everything in the bracket is raised to the power 5. So you have to multiply 5 with the power of x, which is 2, and multiply 5 with the power of y, which is 3. And that is why we have minus 3x raised to power 2 times 5 y raised to power 3 times 5. So you have your answer to be minus 3x raised to power 10 y raised to power 15. Notice that minus 3 is not in the bracket, so you cannot raise it to the power of 5. Minus 3 is not a part of the bracket, so it will not be raised to the power of 5. X, this is number 2, x raised to power minus 9 divided by y raised to power 0 is equal to x raised to power minus 9 over y raised to power 0. And you know that y raised to power 0 is 1. 0 law, 0 index law. So x raised to power minus 9 over 1 is equal to x raised to power minus 9. X, the final answer will now be equal to 1 over x raised to power 9. Always remember to change your final answer to positive index. This answer now, x raised to power minus 9, is in negative index. So to change it to positive index, it is equal to 1 over x raised to power 9. Question number 3, solution. Minus 4m squared n bracket, all in brackets, raised to power 3 is equal to minus 4 raised to power 3, m raised to power 2 times 3, and n raised to power 1 times 3. As you can see, minus 4 is in the bracket, so you also raise it to the power of 3. So we'll have our final answer to be equal to minus 64 m raised to power 6 n raised to power 3. Question number 4, solution. Minus 4x squared y raised to power minus 4, all in brackets, raised to power 2, all over 8xy. Negative quantity raised to an even power is positive. So when you raise a negative quantity to an even power, it is positive. Simply put, minus 4 raised to power 2 is equal to minus 4 times minus 4, which is equal to 16. Minus 4 raised to power 4 will be equal to minus 4 times minus 4 times minus 4 times minus 4. And at the end of the day, you find out that the whole negative signs will cancel out to become plus. And that is what they mean by any negative quantity raised to an even number power is positive. But assuming you are raising it to an odd number power, minus 4 raised to power 3 will be equal to minus 4 times minus 4 times minus 4, which is equal to minus 64. Because minus 4 times minus 4 is 16. 16 times minus 4 is minus 64. So you see the difference. Let's continue. Minus 4x squared y raised to power minus 4 all in brackets raised to power 2 all over x 8xy is equal to plus 4 raised to power 2 times 2 times plus 4 raised to power 2x raised to power 2 times 2 y raised to power minus 4 times 2 all over 8xy will be equal to 16x raised to power 4 y raised to power minus 8 over 8xy. The answer will be equal to 2x when you divide 16 by 8. You have 2. So you have 2x raised to power 4 minus 1 because of this x. 8xy is equal to 8 times x raised to power 1 times y raised to power 1. Remember that anything raised to power 1 is equal to that number. So when you have x raised to power 1 is equal to x, and that is why we just have just x here. But it has a power and it is 1. So you subtract that 1 from the power of x on top. So you have 2x raised to power 4 minus y. You also do the same thing to y. Y raised to power minus 8 minus 1 and is equal to 2x raised to power 3 y raised to power minus 9. This is your final answer. 2x raised to power 3 all over y raised to power 9. This is 2x raised to power 3, not 2 raised to power x3. This is 2x raised to power 3 all over y raised to power 9. Law for fractional index. A raised to power 1 over n, comma, a raised to power m over n. A raised to power 1 over n is equal to a raised to power 1 over n is equal to a root n. A raised to power 1 over m is equal to a root m. So a raised to power m over n is equal to a root n bracket raised to power m, or a raised to power 1 over n bracket raised to power m. So you can either represent it in this way or in this way. Any number raised to the power of 1 over n is equal to the nth root of the number. The nth root of the number. A over b raised to power minus m over n is equal to b over a. There will be a reverse. B over a all in brackets raised to power m over n. So because of the negative sign, a over b will change to b over a, and then we now have m over n. Now the power is in positive. We'll now go ahead to convert m over n. B over a raised to power m over n will now be equal to b over a root n, all in brackets, raised to power m. You will understand more when we solve some examples on this. Examples on laws for fractional index. Simplify the following. Number 1, 35 raised to power minus 1 over 5, bracket 81 raised to power 1 over 2, plus 38 raised to power 0. Number 2, y raised to power minus 3 times y raised to power 2, all in brackets, raised to power 1 over 2, all over y raised to power minus 7. Question number 3. Cube root of 4 raised to power 1.5. Number 4. 0.027 raised to power minus 2 over 3. Solution to number 1. 32 raised to power minus 1 over 5, bracket 81 raised to power 1 over 2, plus 38 raised to power 0. 32 raised to power 1 minus 1 over 5 is equal to 1 over 32 raised to power 1 over 5. 81 raised to power 1 over 2 is equal to square root of 81. And 38 raised to power 0 is equal to 1. So we have 1 over 5 root 32, bracket 9 plus 1. So 32 root 5 is equal to 2, because 2 times 2 times 2 times 2 times 2 is equal to 32. Sorry, this is 32. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So 5 root 32, 5 root 32 is equal to 2. So therefore we have 1 over 5 root 32, bracket 9 plus 1 to be equal to 1 over 2 times 10, which is equal to 5. Solution to question number 2. Y minus 3 times y raised to power 2, all in brackets, raised to power 1 over 2, divided by y raised to power minus 7. And it is equal to y raised to power minus 3 plus 2, all in brackets, raised to power 1 over 2, divided by y raised to power minus 7. So it's equal to y raised to power minus 1, that is minus 3 plus 2 is equal to minus 1. So we have y raised to power minus 1 raised to power 1 over 2, all over y raised to power minus 7. And is equal to y raised to power minus 1 minus minus 7. Law of division. So we have minus 1 minus minus 7. So y raised to power minus 1 minus minus 7 is equal to y raised to power minus 1 plus 7. All raised to power, all in brackets, raised to power 1 over 2. So you have y raised to power minus 1 plus 7 is equal to 6. So you have y raised to power 6 times 1 over 2. So product of indices, we have y raised to power 6 raised to power 1 over 2 is equal to y raised to power 6 times 1 over 2. So we'll have the final answer to be y raised to power 3. Solution to number 3. Cube root of 4 raised to power 1.5 is equal to, this is cube root, when 3 is outside, it's cube root. So cube root of 4 raised to power 15 over 10. You know that 1.5 is equal to 15 over 10. Reducing 15 over 10 to the lowest term, we have, when you divide by 5, 15 divided by 5 is equal to 3. 10 divided by 5 is equal to 2. So you have 3 over 2. So you can also represent cube root of 4 raised to power 15 over 10 can be written as cube root of 4 raised to power 3 over 2. And this is equal to 4 raised to power 3 bracket 1 over 2. You know that 3 times 1 over 2 is equal to 3 over 2. So if we take in 3 and leave 1 over 2 outside the bracket, we have cube root of 4 raised to power 3. And cube root of 4 raised to power 3 is equal to 4. Because this power 3 will cancel out this root 3. So we are left with 4 raised to power 1 over 2. And that is how we arrived at this. So this cube root of 4 raised to power 15 over 10 is equal to 4 raised to power 1 over 2. And 4 raised to power 1 over 2 is equal to square root of 4. And the square root of 4 is 2. So your final answer is 2. Solution to number 4 question. 0.027 raised to power minus 2 over 3 is equal to, changing 0.027 to fraction, we have 27 over 1000 raised to power minus 2 over 3. Because of the negative sign of the power, we'll have the reverse. That is 1000 over 27 raised to power 2 over 3. And is equal to cube root of 1000 over 27 raised to power 2. So when you find the cube root of 1000 over 27 is equal to 10 over 3. Cube root of 1000 is equal to 10. Cube root of 27 is equal to 3. That is 3 times 3 times 3 is equal to 27. So the cube root of 27 is 3. So we have 10 over 3 raised to power 2. So when you square 10 over 3, you have 10 times 10, 100. 3 times 3, 9. So you have 100 over 9. And 100 over 9 is equal to 11 whole number 1 over 9. This is wrong. It is 11 whole number 1 over 9. Not raised to power 1 over 9. So this is the answer. 11 whole number 1 over 9. Prime factors in index forms. The base of an index could be expressed in its prime factors. Examples. Evaluate the following. 30 raised to power 2a minus 6 raised to power 2a. Number 2. 8 raised to power 1 over 3 times 5 raised to power 2 over 3 all over 10 raised to power 2 over 3. Number 3. 24 raised to power 1 over 2 times 27 raised to power 1 over 3 times 16. So we'll look at the solutions to these questions. Solution to example 1. 30 raised to power 2a minus 6 raised to power 2a is equal to 30 divided by 6 bracket 2a and is equal to 30 over 6, which is equal to 5 raised to power 2a. So answer is 5 raised to power 2a. Another method of solving this is 30 raised to power 2a minus 6 raised to power 2a is equal to 30 divided by 6. This is divided. 30 divided by 6 raised to power 2a is equal to 30 over 6 bracket raised to power 2a. So when you find the prime factors of 30, 2 times 3 times 5, all over 2 times 3, which is that of 6, we'll have 2 times 3 will cancel out 2 times 3, leaving behind 5. So we'll have 5 raised to power 2a. Still the same answer. Solution to example 2. 8 raised to power 1 over 3 times 5 raised to power 2 over 3 divided by 10 raised to power 2 over 3. Break the bases to their prime factors. So find the prime factors of 8, which is 2 times 2 times 2. And that is 2 raised to power 3. So we now have 2 raised to power 3 times 1 over 3 times 5 raised to power 2 over 3 divided by 2 times 5, prime factors of 10. 2 times 5 raised to power 2 over 3. So we have 2 times 5 raised to power 2 over 3. This 2 is from this 2 times 2 raised to power 3. 2 raised to power 3 times 1 over 3. 2 raised to power 3 times 1 over 3 is equal to 2 raised to power 3 over 3. And 3 over 3 is 1. So we have 2 raised to power 1, which is equal to 2. So that is how these two came about. So we have 2 times 5 raised to power 2 over 3 divided by 2 raised to power 2 over 3 times 5 raised to power 2 over 3. You separate the bases. So you raise 2 to the power of 2 over 3 and raise 5 to the power of 2 over 3. So 5 raised to power 2 over 3 will cancel out. And you are left with 2 over 2 raised to power 2 over 3. So this is it, 2 raised to power 1 all over 2 raised to power 2 over 3. Since they are in the same base, which is 2, you subtract the powers. So you have 1 minus 2 over 3, which is equal to 2 raised to power 3 minus 2 over all over 3. And you have your answer to be 2 raised to power 1 over 3, or cube root of 2. This is wrong, it is cube root of 2. Solution to example 3. 24 raised to power 1 over 2 times 27 raised to power 1 over 3 times 16. Change the base to prime factors. We have factors of 24, 2 times 2 times 2 times 3 raised to power 1 over 2. Factors of 27, 3 times 3 times 3, which is equal to 3 raised to power 3 times 1 over 3. Because the power of 27 is 1 over 3, when you change the base to the prime factors, as we've done here, to get 3 over 3, you multiply it by the original power, 1 over 3. So you have 3 raised to power 3 times 1 over 3. And then 16 is equal to 2 times 2 times 2 times 2. That is 2 raised to power 4. So we have 2 raised to power 3 times 1 over 2 times 3 raised to power 1 over 2. You know that 24 is equal to 2 times 2 times 2 times 3, which is also equal to 2 raised to power 3 times 3 raised to power 1. So since the power of 24 is 1 over 2, so you also raise 2 raised to power 3 to power of 2, and then this to the power of 1 over 2 also. So you have 2 raised to power 3 times 1 over 2 times 3 raised to power 1 times 1 over 2. And 1 times 1 over 2 is 1 over 2. And that is what we have here. Times 3 raised to power 1. This 3 raised to power 1 is from 3 raised to power 3 times 1 over 3. 3 times 1 over 3 is 1. So you have 3 raised to power 1. Then times 2 raised to power 4. 2 raised to power 3 over 2 times 2 raised to power 4 times 3 raised to power 1 over 2 times 3 raised to power 1. So you collect like terms. You bring the numbers with the same bases together, and then you add up the powers. So we have 2 raised to power 3 over 2 plus 4 times 3 raised to power 1 over 2 plus 1, which is equal to 2 raised to power 11 over 2 times 3 raised to power 3 over 2. This is 3 over 2. 1 over 2 plus 1 is equal to 3 over 2. So we have 2 raised to power 11 over 2 times 3 raised to power 3 over 2. So this is your final answer. Exponential equations and rational index powers. Examples. Solve the following equations. X raised to power 1 over 3 is equal to 5. B raised to power 2 over 3 is equal to 16. 2x is equal to 16x raised to power 1 minus 1 over 2. Question 4. 8x minus 1 is equal to 64. Solution to number 1. X raised to power 1 over 3 is equal to 5. That's question number 1. To solve this, raise both sides of the equation to the inverse of the power of x to clear the fraction. So we have x raised to power 1 over 3 times 3. Inverse of 1 over 3 is equal to 3 over 1, which is 3. So when you multiply x raised to power 1 over 3 by 3, when you raise the power of x raised to power 1 over 3 by 3, you also raise the power of 5 by 3. So we have x raised to power 1 over 3 times 3 equal to 5 raised to power 3. And x raised to power 1 over 3 times 3 is equal to 1. Is equal to x raised to power 1. And so we have x equal to 5 raised to power 3. Know that x raised to power 1 is equal to x. We have x is equal to 5 raised to power 3. And 5 raised to power 3, which is 5 times 5 times 5, is equal to 125. Therefore, x is equal to 125. And that's the answer to question number 1. Solution to number 2. Number 2 says b raised to power 2 over 3 is equal to 16. We also do the same thing as before. We raise both sides of the equation to the inverse of the power of b. This time is b, power of b, to clear the fraction, and we'll have b raised to power 2 over 3 times 3 over 2. 3 over 2 is the inverse of 2 over 3. So b raised to power 2 over 3 times 3 over 2 is equal to 16 raised to power 3 over 2. 2 over 3 times 3 over 2 is equal to 1. And b raised to power 1 is equal to b. So we'll have b is equal to 16 raised to power 3 over 2. And 16 raised to power 3 over 2 is equal to square root of 16 raised to power 3. So we have b is equal to square root of 16 raised to power 3. And square root of 16 is 4. So b is equal to 4 raised to power 3. And 4 raised to power 3 is equal to 16. So b is equal to 4 raised to power 3 is equal to 64. So b is equal to 64. Solution to number 3. Question number 3 says 2x is equal to 16x raised to power minus 1 over 2. 16x raised to power minus 1 over 2. That is 16x raised to power minus 1 over 2. So you divide both sides by the coefficient of x, which is 2. So 2x divided by 2 is equal to 16x raised to power minus 1 over 2 divided by 2. So we have 2x over 2 is x, and then 16x raised to power minus 1 over 2 divided by 2 is equal to 8x raised to power minus 1 over 2. So x raised to power 1, which is this, times x raised to power 1 over 2 is equal to 8. When you collect like terms, so this x will go to this side, leaving 8 behind. So we have x raised to power 1 plus 1 over 2 is equal to 8. 1 plus 1 over 2 is equal to 3 over 2. So we have x raised to power 3 over 2 is equal to 8. Now, we'll multiply both sides of the equation by the inverse of the power of x. We have x raised to power 3 over 2 times 2 over 3 is equal to 8 raised to power 2 over 3. We'll have x to be equal to cube root of 8 raised to power 2, and cube root of 8 is 2. So x is equal to 2 raised to power 2. That's 2 squared and is equal to 4. So your final answer is x equal to 4. Solutions to number 4. 8x raised to power minus 1 is equal to 64. Divide both sides by 8 so that x will have no coefficient. We want to make this x to be on its own. So you remove this coefficient. So how do you do that? You divide by 8. So when you divide 8x minus 1 over 8 and you do the same thing to 64, you have x raised to power minus 1 is equal to 8. 64 over 8 is 8. So x raised to power minus 1 is the same as 1 over x. So we have 1 over x is equal to 8. It implies that 1 over x is equal to 8 over 1. So when you cross multiply, you have 8x, 8 times x, 8x equal to 1 times 1, 1. Now divide both sides by the coefficient of x, which is 8. So when you divide again by 8, you have 8x over 8 equal to 1 over 8. And you have x to be equal to 1 over 8. And this is the final answer. This is the answer to this number 4 question. X equal to 1 over 8. Further examples of exponentials equation. Solve the following equations. 1. 4 raised to power x minus 1 is equal to 64. 2. 2y raised to power minus 3 is equal to minus 16. Number 3. 3 cube root of 8x, that is 8x is equal to 6. This is question number 3. Cube root of 8x is equal to 6. Number 4. 4 raised to power 3 plus m all over 8 raised to power 10m. 4 raised to power 3 plus m all over 8 raised to power 10m is equal to 2 raised to power 215 minus m all over 4 raised to power 9m. And then this number 6 is number 5, this is 6, and this is 7. So number 5, 27 raised to power 3x plus 1 over 2 is equal to 9 raised to power 5x minus 1 over 4. Number 6, 5 raised to power 1 over x is equal to 1 over 125. And number 7, 1 over 4 brackets 4 raised to power x 4x raised to power minus 2 is equal to 1 over 8. So we'll solve these questions one after the other. Solution to number 1. 4 raised to power x minus 1 is equal to 64. First, you change both sides of the equation to the same base and then equate the powers. We have 4x raised to power minus 4 raised to power x minus 1 is equal to 4 raised to power 3. 64 is equal to 4 times 4 times 4. And that is 4 raised to power 3. So now you cancel out the bases. We have x minus 1 is equal to 3. You are not dealing with the powers. X minus 1 is equal to 3. When you collect like terms, you have x to be equal to 3 plus 1. Minus 1 crosses the equal sign to become plus. So you have plus 1. So x is equal to 3 plus 1, which is equal to 4. Another way to solve this is 4 raised to power x minus 1 is equal to 4 raised to power 3. If you change the basis to index form, you have 2 raised to power 2 bracket x minus 1. 2 raised to power 2 is 4. So what we did is to break down this 4, change it to base 2. And then we did the same side to the other side. We did the same thing to the other side of the equation. That is 4 raised to power 3. And 4 raised to power 3 is now become 2 raised to power 6. Because 4 is equal to 2 raised to power 2. And since the initial power of 4 is 3, we also multiply it, raise it to the power of 3. 2 times 3 is 6. So you have 2 raised to power 6. So we have that 2 raised to power 2x minus 2 is equal to 2 raised to power 6. Cancel out the bases, you have 2x minus 2 is equal to 6 plus 2. So we have 2x equal to 6 plus 2. 2x is equal to, divide both sides by 2. You have 2x over 2 is equal to 6 plus 2 is 8. So 8 over 2 you have x to be equal to 4. And it's the same answer we got before, x equal to 4. Question number 2 says 2y raised to power minus 3 is equal to minus 16. So you divide through with 2 to cancel out the coefficient of y. So you have 2y raised to power minus 3 all over 2 equal to minus 16 over 2. You have y raised to power minus 3 equal to minus 8. Raise both sides of the equation to the inverse of the power of y to clear the fraction. And the inverse of minus 3 is equal to minus 1 over 3. So you have y raised to power minus 3 times minus 1 over 3 is equal to minus 8 raised to power minus 1 over 3. Y is equal to minus 1 over 8 raised to power 1 over 3. So y is equal to minus 1 over cube root of 8. And the cube root of 8 is equal to 2. So y is equal to minus 1 over 2. And this is your final answer. Solution to question number 3. Question number 3 says cube root of 8x is equal to 6. So to solve this, you raise both sides of the equation to the inverse of the power of x to clear the fraction. And in this case, the power of x here is, the power of 8x, is 1 over 3. 8x raised to power 1 over 3 is equal to cube root of 8x. So the power of 8x in this question is 1 over 3. So the inverse is 3. So you multiply both sides of the equation. You raise both sides of the equation to the power of 3. So you have cube root of x, cube root of 8x, bracket raised to power 3. So that this 3 will cancel out this 3. Together with this root, equal to 6 raised to power 3. 6 raised to power 3 is equal to 216. So we have 8x is equal to 216. Divide both sides by 8 to remove the coefficient of x, which is 8. So you have 8x over 8 is equal to 216 over 8. This 8 will cancel out. 216 over 8 is equal to 27. So you have x to be equal to 27. Solution to number 4. Number 4 question said 4 raised to power 3 plus m all over 8 raised to power 10m is equal to 2 raised to power 215 minus m all over 4 raised to power 9m. Change all the bases to base 2. Changing 8 to base 2, you have 2 raised to power 3. Changing 4 to base 2, you have 2 raised to power 2. So you have 2 raised to power 2 bracket 3 plus m all over 2 raised to power 3 bracket 10m. Either I use brackets or times, they're the same thing. So 2 raised to power 3 times 10m is equal to 2 raised to power 215 minus m all over 2 raised to power 2 times 9m. So we have 2 raised to power 6m plus 2m all over 2 raised to power 30m equal to 2 raised to power 215 minus m all over 2 raised to power 18m. So you cross multiply. You have 2 raised to power 30m times 2 raised to power 215 minus m equal to 2 raised to power 18m times 2 raised to power 6 plus 2m. You have it to be equal to 2 raised to power 30m plus 215 minus m is equal to 2 raised to power 18m plus 6 plus 2m, which is equal to 2 raised to power 29m plus 215m. See what happened here. We had 2 raised to power 30m plus 215 minus m. We are collecting like terms now. Initially we had 2 raised to power 30m plus 2 raised to power 215m. But since they are in the same base, we just pick 2 and then add up the powers. And we have 2 raised to power 30m plus 215 minus m. So when you collect like terms, 30m minus m is 29m. So you have 2 raised to power 29m plus 215. This m will no longer be here. It is 215 minus m. So it will be 2 raised to power 29m plus 215 equal to 2 raised to power 18m times 2 raised to power 6 plus 2m is equal to 2 raised to power 18m plus 6 plus 2m. Since they are in the same base, 2, you just pick 2 and then add up the powers. So you have 18m plus 2m equal to 20m, then plus 6. And that is what we have here. So your answer will be removing the base, which is 2. By dividing both sides by 2, you have 29m plus 215 is equal to 20m plus 6. When you collect like terms, you have 29m minus 20m is equal to 6 minus 215. 9m is equal to minus 209. When you subtract, when you solve this and solve this, you have 9m equal to minus 209. So divide both sides by the coefficient of m, which is 9. You have 9m over 9 is equal to minus 209 over 9. And so you have m to be equal to minus 23 whole number 2 over 9. 209 over 9 is 23 whole number 2 over 9, not 2 raised to power 9. It's 2 over 9. So m is equal to minus 23 whole number 2 over 9. Solution to number 5. 27 raised to power 3x plus 1 over 2 is equal to 9 raised to power 5x minus 1 over 4. Factorizing the powers, we have 27 raised to power 6x plus 1 all over 2 equal to 20x minus 1 all over 4. Changing to base 3 will give us 3 raised to power 3 bracket 6x plus 1 over 2. There should be 3 here. Changing 27 to base 3, you have 27 is equal to 3 raised to power 3. So it will now become 3 raised to power 3 bracket 6x plus 1 all over 2 equal to 3 raised to power 2 bracket 20x minus 1 over 4. Cancel out 2 and 4 and multiply out to get 3 bracket 3 raised to power bracket 18x plus 3. That is when you use this 3 here to multiply, to open up this bracket. 3 times 6x, 18x. 3 times 1, 3. So you have 3 raised to power 18x plus 3 over 2 is equal to 3 raised to power 20x minus 1 over 2. When you divide 4 by 2, you have 2 here. So that is how we eliminated these 2. We now have 3 raised to power 20x minus 1 over 2. Cancel out the base 3. We have 18x plus 3 is equal to 2. 18x plus 3 over 2 equal to 20x minus 1 over 2. Cross multiply, you get 2 times 2 bracket 20x minus 1 equal to 2 bracket 18x plus 3. Open up the bracket. 2 times 20x, we have 14x. 2 times minus 1, minus 2. So we have 40x minus 2 equal to 36x plus 6. Collecting like terms, we have 40x minus 36x is equal to 2 plus 6. So we have 4x equal to 8. X equal to 8 over 4. So you have your final answer to be x equal to 2. Solution to question number 6. Question says 5 raised to power 1 over x is equal to 1 over 125. Change 125 to base 5. You have 5 raised to power 3. 125 is equal to 5 raised to power 3. That is 5 times 5 times 5. So 5 raised to power 1 over x is equal to 1 over 5 raised to power 3. And 1 over 5 raised to power 3 is equal to 5 raised to power minus 3. So we have 5 raised to power 1 over x to be equal to 5 raised to power minus 3. Cancel out the base 5 to have 1 over x is equal to minus 3. When you cross multiply, you have minus 3x minus 1 over x is equal to minus 3. Cross multiply, you have minus 3x is equal to 1. Divide by the coefficients of x, we have minus 3x over 3 over minus 3 equal to 1 over minus 3. X is equal to minus 1 over 3. Solution to number 7. Question number 7 says 1 over 4 raised to bracket 4 raised to power x minus 2 is equal to 1 over 8. Multiply both sides by 4 to cancel out the coefficient of 4x raised to power minus 2. So you have 4 times 1 over 4 bracket 4 raised to power x minus 2 equal to 4 times 1 over 8. So 4 times 1 over 8 is equal to 1 over 2. And that is what we have here. So we have 4 times 1 over 4 bracket 4x minus 2 to be equal to 1 over 2. 4 times 1 over 4 is equal to 1. So we have 4 raised to power x minus 2 is equal to 1 over 2. And 1 over 2 is equal to 2 raised to power minus 1. So finally we have 2 raised to power 2 bracket x minus 2. That is changing 4 to base 2. You have 2 raised to power 2 bracket x minus 2 is equal to 2 raised to power minus 1. 2 raised to power 2x minus 4 is equal to 2 raised to power minus 1. Cancel out the bases. We have 2x minus 4 is equal to minus 1. So since they are in the same base, you can just cancel out the base and work with the powers. So we have 2x minus 4 is equal to minus 1. Collecting like terms, we have 2x equal to minus 1 plus 4. This is 2x equal to minus 1 plus 4, not minus 2. Minus 1 plus 4. And minus 1 plus 4 is equal to 3. So 2x is equal to 3. Divide through by 2. X is equal to 3 over 2, which is equal to 1 whole number 1 over 2. So x is equal to 3 over 2, or 1 whole number 1 over 2. So this is wrong. This is the answer. Don't get confused by the mistake. Another exercise, solve the following. If a squared b cubed b raised to power 3 c all in bracket raised to power 3 over 4 all over a raised to power minus 1 b raised to power 4 c raised to power 5 is equal to a raised to power b, b raised to power q, and c raised to power r. What is the value of p plus 2q? Also simplify 9 raised to power 1 over 3 times 27 raised to power minus 1 over 2 all over 3 raised to power minus 1 over 6 times 3 raised to power minus 2 over 3. So this is an exercise for you to solve. We've come to the end of this section, but let's take a look at what we've done so far. Laws of indices. If a is equal to 0 and m and n are integers, that is negative and positive numbers, the following laws hold. A raised to power m times a raised to power n is equal to a raised to power m plus n, and this is the law of multiplication. A raised to power m divided by a raised to power n is equal to a raised to power m minus n. And this is the law of division. A raised to power m bracket n is equal to a raised to power m times n, which is equal to a raised to power mn. And this is the product of indices. Law of product of indices. A raised to power 0 is equal to 1. And this is the zero law for index. A raised to power minus m is equal to 1 over a raised to power m. And this is the law for negative index. Any number raised to the negative number index or power is equal to the reciprocal of the number raised to the same but positive index or power. Laws for fractional index. A raised to power 1 over n, a raised to power m over n. A raised to power 1 over n, this 1 over m, this is m. A raised to power 1 over m is equal to mth root of a. That is a root of m. A raised to power m over n is equal to nth root of a bracket raised to power m, or a raised to power 1 over n, which is equal to a raised to power 1 over n bracket m, which is equal to nth root of a bracket raised to power m. Any number raised to the power of 1 over n is equal to the nth root of the number. For example, a over b raised to power minus m over n is equal to b over a raised to power m over n, and is equal to nth root of b over a raised to power m. And with this, we come to the end of this section. Thank you.